Hi, in this video, I will be presenting my VFD diagram and simulation. Now for my diagram, there we can find a circuit breaker which serves as a protection for our device in case problems like short circuit. Now there are three wires that are coming from it, which is the line 1, 2, and 3, that is directly connected to the inverter. Now, as for our inverter, we can find that our from terminal 27, there are two other terminals that are connected to it, which is the terminal 12 and terminal 20. Our device has two types of push button, which is the first is the normally open for the start button and the normally closed for the stop button. For the start button, one of its wire is connected to terminal 12, while the other one is connected to terminal 18. As for our stop button, one of its wire is connected to terminal 13, while the other is connected to terminal 27. For our potentiometer, there are three wires that are connected to three different terminals to the inverter, which is the terminal 55, 54, and 53. Now from the inverter, there are three other wires that go directly to our three-phase motor. Now for our three-phase motor, here is our spec. Now using this spec, let's use our simulation, which is the LCP simulator by Danfoss. To use this, go to quick menu, then proceed to quick setup. Our default language is English, so skip that. Skip. For our motor power, we need to convert our horsepower. Our horsepower is 3 horsepower. Now the equivalent value in terms of kilowatt is 2.24. So let's change it. Let's input the value of our kilowatts in terms of that we got from its horsepower, which is 2.24. Once you're done inputting it, press OK, then next. Now for our motor voltage, our value is 460. So let's change that. Then OK, next. Our motor frequency, our motor frequency has a value of 60 Hz. Next. As for our motor current, we need to multiply the value of our ampere and our surface factor. Our ampere has 4.2 and our surface factor has 1.15. So when you multiply it, we get 4.83. So input value 4.83 and press OK. Next, motor nominal speed, which is in terms of RPM. The RPM of our motor is 1750. So next, our ramp up time is let's input our ramp up time in 15 seconds. Now next is our ramp up. Next is our ramp down time. Like the ramp up, let's change this into 15 seconds. Press OK. The next is our motor speed low limit. So let's just skip that since it already is 0 RPM. As for our high speed limit, let's change this into 1750. Okay, then next. Now once you're done, click status, then hand on. Since the value for here in our RPM is 0, the indicator is at the lowest. Now, if we change that into 1750, you can see that the indicator is slowly going to its highest value. Now, the next step for our simulation is proceed to the main menu, then go to the digital in and out, digital inputs. Now, we can see that this is in 8 or in start, so we need to change that into 9, which is the latch start. Press OK. Next is we also need to change this, since this is in cos inverse, so we need to change this into stop inverse. Now, next is we need to go to the main menu, go to the analog in and out, analog input 53, skip. Now, for our higher reference or feedback value, we need to change this into 1750. Press OK. Next is we need to next. Okay, since we're done with that, let's go back to the main menu and next. Okay, let's go to the reference or ramps, reference limits. Now our minimum reference, which is already in 0, so let's skip that. Now for our maximum, let's change this into 1750. Okay, next. Okay, once you're done, go to status, then auto hands-on. Now, once you're done with all that, we can see this in our simulation in our LCP simulation or simulator. Now, that is all for this video. Thank you for watching. I hope this video is meaningful to you. See you next time.